Hey, hello. This video is on the topic absolute convergence and tests for absolute convergence. So let's begin by considering this series. So given by this expression, so summation n from 1 to infinity sine n over n squared. So the first few terms of this series are, so when n equals 1, we have when n equals 1, sine 1 over 1. The second term is when n is equal to 2. So we have sine 2 over 4. When n is 3, sine 3 over 9. When n is 4, sine 4 over 16, and so on. So the question that we want to answer is this series convergent or divergent? So isipin natin, so far meron tayong alam na tests for convergence or divergence. Nandiyan ang divergence test. Sa divergence test, i-check natin ang limit na a sub n, okay, as n goes to infinity. Ang a sub n in this example is this expression, sine n over n squared. So kapag kinuha natin yung limit ng a sub n as n goes to infinity, saan equal? Pwede natin isipin sine n, yung value nito ay between minus 1 and 1. So as n goes to infinity, this one gets bigger and bigger. So ang effect sa buong expression ay pupunta siya to 0. So kung gagamitin ang divergence test, actually pwede ba? Dahil yung limit ay 0, divergence test is not applicable in this example. So ano pang tests yung available sa atin? So nandiyan ang integral test, comparison test, limit comparison test, and yung test na lesson nyo last meeting ay alternating series test. So ito bang mga tests na ito ay applicable in this example? So let's check. Ano ba ang requirement? Ano ang assumption na kailangan ma-satisfy before using integral test, comparison test, limit comparison test? Kailangan mo doon yung non-negativity o positive ang terms, no? And so on. Sa integral test, meron pang ibang assumptions. So, dun sa positive terms ng series, tignan natin ulit yung a sub n, yung nth term ng series. And let's observe na, so itong 1, 2, and 3, ang terminal side nito nasa quadrant 1 or 2. Hence, yung sign doon ay positive. So, sine 1, sine 2, sine 3, positive numbers. On the other hand, itong 4, terminal side quadrant 3, so ang sign doon ay negative. 3 sine 5, sine 6 ay negative numbers, you can verify. Pero ang sine 7 positive. No? So anong point nun? So ang tatlong tests na ito, pwede ba nating ma-apply in this example? Hindi, no? Kasi merong terms yung ating series na negative. What about AST? Pwede ba siyang magamit? So clearly, hindi rin pwedeng magamit, no? Ang AST. Dahil ang AST pwede mo lang gamitin, nasa pangalan, for alternating series. And malinaw, hindi alternating in sign ang series na given. So pakita ko lang yun. Anong gagawin natin ngayon? So observe that some terms are positive and some are negative. In fact, sine 1, sine 2, sine 3, katulad ng sabi natin kanina, positive. While sine 4, sine 5, sine 6, negative numbers. You can verify yung mga susunod, merong positive, merong negative. So hindi lahat ng terms ng series ay positive, hence itong tatlo ay not applicable. Integral test, comparison test, limit comparison test. AST, syempre hindi siya applicable kasi hindi alternating series. Ano nang gagawin natin? So pwede natin ngayon i-consider ang absolute convergence. So how do we determine whether the given series converges or diverges? We can consider absolute convergence. So in the next slide, we define ano ba itong absolute convergence. So clear. Okay. Next. So ito yung definition. A series A sub n is said to be absolutely convergent if the series with absolute values, no, A sub n absolute value, is convergent. We define also what it means to be conditionally convergent. So this series is said to be conditionally convergent if this series is convergent, but this series, yung may absolute value, is divergent. Some examples. So let's look at this series. Ito yung alternating harmonic series. And we know that the alternating harmonic series is convergent. No? So itong series na ito, naipakita natin. Ipakita natin last meeting. Actually, pwede mong maipakita na by AST convergent. No? Convergent by AST. So, pwede natin itanong next, anong type of convergence ang meron sa alternating harmonic series? To know the answer, let's consider yung series of absolute values. So, if this series ay convergent, then yung type of convergence is absolute. While if this series is divergent, then yung type of convergence ng alternating harmonic series is conditional. So, tignan nyo lang, ano ba ang absolute value ng A sub n? Teka. So, ang absolute value ng A sub n, syempre 1 over n. So, let's consider the series with terms 1 over n. And itong series na to, very familiar sa atin, harmonic series. And we know that the harmonic series is divergent. So, kung babalik tayo sa definition, this series, alternating harmonic series, is convergent. So which type? Let's consider yung series of absolute values. This series is divergent dahil harmonic series siya. Therefore, ang type of convergence is conditional. So another example, So let's clear. So another example, let's consider this series. So yung nakasulat na absolutely convergent siya. No? So tignan natin. So first question, is this series convergent? Ano kayang pwedeng test yung i-apply para ma-determine kung yung series ay convergent? So mukhang pwede dito ang AST. No? So mabilis maipakita, kayo na lang mag-verify that this series is convergent, no? By AST. Okay. So dahil convergent siya, pwede nating itanong anong type of convergence yung meron sa series na ito. So to determine which type of convergence, check lang natin kung convergent or divergent yung series of absolute values. Pero kung titignan nyo, magiging lang siya, summation 1 over n squared. And very easily alam ninyong yung series na yun ay 1 over n squared. Okay. So, syempre ito ay convergent. Bakit? Kasi ito ay P series with P equal to 2 and yun ay greater than 1. So dahil convergent yung series of absolute values, ang type of convergence ng ating original na series ay absolute. Katulad ng sabi dito. Okay. 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 Sige, next. So next, let's consider this theorem. So it says that if this series, yung series of absolute values, is convergent, then this series, yung without the absolute value, is also convergent. So itong theorem na ito, pwede nyo din siyang gamitin to show convergence ng series na ito. So para magamit yun, titignan mo muna or i-determine mo muna if this series is convergent, yung may absolute values. So bago tayo mag-example, pakita natin yung proof. So ito yung assumption. The series with absolute values is convergent. So we want to show that yung walang absolute value is also convergent. So to show this, note that this statement is true for all n. A sub n can be positive or negative. I always between minus absolute value a sub n and absolute value a sub n. Next, we add a sub n absolute value sa all sides, in all sides. No? Meron kang 0 on this side, a sub n plus absolute value a sub n sa gitna, twice absolute value a sub n sa rightmost. Okay. Next, balikan lang natin yung assumption that this is convergent. No? So magpa-follow una, dahil convergent ito, then yung series na ang terms ay twice ng absolute value a sub n is also convergent. Meron tayong theorem no, on that. So another thing na magpa-follow, so dahil ito, yung series na ito yung terms ay convergent, then yung series na ang terms ay a sub n plus absolute value ng a sub n ay convergent din. Bakit? Magpa-follow yun by comparison test. No? So note important dito yung 0 less or equal to this expression kasi pinapakita na ang terms ng series na ito ay non-negative. Okay. So from this line, magpa-follow ay two things. So first, itong series na ito, twice lang nung original, nung assumption, convergent din. And then by comparison test, ito mas malaki. Then yung series na ang terms ay this one ay also convergent no, by comparison test. Okay. So ito yung gusto nating pakita, no? Convergent itong a sub n series. So from this line, punta tayo sa next. So observe that, ito yung gusto nating ipakita na convergent. No? Pwede natin siyang i-rewrite in this way. So malinaw naman yan, tama siya. Pero dahil itong series na ito, ang terms ay a sub n plus absolute value ng a sub n, and this series ay convergent. No? So dahil parehong convergent sila, then this series on the left side ng equation, equality natin, convergent din dapat. No? So meron tayo ulit yung property sa previous lecture ninyo. So itong right-hand side na series convergent, then itong left side, ito yung gusto nating ipakita, ay convergent din. Okay. So ito ulit yung theorem. So we can use this no, to show convergence ng ng series with terms a sub n. So pwede tayong dumaan dito. No? So ito muna yung, i-check natin yung convergence muna ng series of absolute values. So example, balik tayo dun sa problem natin kanina. Ito yung series na ang terms ay sin n over n squared. So alam natin na divergence test, comparison, limit comparison, integral test, and AST, lahat sila not applicable para sa problem na to. So let's try to use yung theorem previously stated. So to do that, we begin by considering yung series of absolute values. No? So summation, sin n over n squared absolute value, n from 1 to infinity. Okay. So as you can see, actually sure na tayo na yung a sub n dito ay positive na ang terms, no? Dahil sa absolute value. So let's determine whether the series of absolute values ngayon ay convergent or not. So ito muna yung ating i-consider. So balikan ulit natin. Divergence test, comparison test, limit comparison test, AST, integral test. Divergence test pwede bang magamit para sa problem na ito? Ganun ulit, no? Check nyo yung limit ng a sub n as n goes to infinity. Hindi magbabago. Ang limit ay 0. So, hindi siya pwedeng gamitin. Not applicable. AST, hindi pa rin applicable dahil not alternating series. What about comparison test, limit comparison test? Pwede na ba silang magamit? Actually, yes, no? Kasi dahil sa absolute value, naging positive na yung terms ng ating series. Ito yung ating a sub n. Hence, applicable na si comparison test, yung ating piliin. Okay. So let's proceed by showing, actually determining whether this series is convergent or not by comparison test. So using comparison test, mag-iisip ngayon tayo sa natin siya i-compare na alam natin sana na convergent or not. Pero kung titignan natin yung problem, pwede nating subukan muna yung series na ang terms ay 1 over n squared. At alam natin na ito ay p-series na convergent. Convergent. Okay. So to show convergence by comparison test, ano ang kailangang ipakita? Okay, so kukompare natin siya dito. So to show convergence, yung inequality na dapat nasa gitna ay dapat siya ay less than or equal to. Okay. And actually, totoo naman to, no? For n equals 1, 2, 3, and so on. So sin n, absolute value, ay bounded by 1, no? And n squared, kopya lang naman. So this inequality is true. Now, since this series is convergent, yung series na ang terms ay 1 over n squared, then yung series na ang terms ay sin n, absolute value over n squared, is also convergent by comparison test. Okay, pakita natin. So using comparison test, so observe that this inequality is true, katulad nung ginawa natin. So hence, so by comparison test, this series is also convergent. Now, pwede na nating i-apply as a last step yung theorem na na-state previously. So since the series of absolute values is convergent, then yung series without the absolute value is convergent, no? By the previous theorem. Okay. And which type of convergence? So, babalik ka dito. Pwede kang bumalik dito. So, we have shown that this is convergent. Hence, yung type is absolute. Okay. So, sa next video, meron pa tayong additional tests na ipipresent.